Hello and welcome to another exciting video for Ken's training. Today we're going to do some troubleshooting on this counter height refrigerator. The complaint is that it's simply not cooling. It's a Sanyo refrigerator. It actually looks like it's only maybe 2 years old. It looks pretty new and it looks nice. It's got a stainless steel front door. I'm not sure what they paid for it. I didn't buy it. Inside there is a thermostat right here, and it's I've set it to the mid position of 3, so it should be on right now. So that's that. I've already tried to plug it in, turn it on, nothing happened, so now we're at the troubleshooting stage. And I'm going to, let's see here. See if I can demonstrate this whole thing. Right now I've got it unplugged and they've got a PTC thermistor here. I'm just going to plug that in. Alright, this cover was on the compressor motor here, but I'm just going to leave that open for now. On the back here it says that the input current should be 0.9 amps. So if I take my meter, put it on amperage, and I grab one wire there going towards the compressor, and if I try and plug it in, I'm going to turn this on. Okay, it went from 5 amps, now it's pulling 3.29 amps, and all I'm hearing is a hum. Okay? So that went, when I turned it on, it goes from 5 amps. Actually, can you superimpose right here on the meter? I'm going to turn it on again, so you'll be able to see exactly what the meter draw is. Okay, here we go. So it just goes to about 3 amps. That's locked rotor amps, and all I'm getting is a hum. So obviously this compressor is not turning. So the question is why is it not turning? Is it not turning because there's a problem with the start winding? Or if you look at the schematic, go ahead and zoom in here on the schematic, and we'll go over the schematic. Can you see it? The electricity comes in through the cord. It goes through a thermostat, it goes in a yellow wire, it comes out a gray wire, then it goes through an overload protector, which is like a fuse in this case, and that goes to one of the compressor terminals. The other 2 terminals, the neutral wire comes in and it goes to a PTC thermistor. Now I'm going to pull out these components so that you can actually see them. Okay. Go ahead and zoom in on this. This is what the schematic is calling the overload protector. Now the spade terminal here plugs in here, and then this terminal here is where it plugs into the compressor. Now I already know that this is good because I took my meter, I put it on ohms. I'll just go on continuity so it makes a beeping sound when you have continuity. If I touch here on where the spade terminal connection, touch here where it touches the compressor, you can clearly hear that I've got continuity through this overload protector. So this is not the reason why this is not starting. We know that. The other device, which is this device right here, is a PTC thermistor. Now, what happens is the neutral wire on the plug that goes to the cord, the neutral wire comes in, and then it has 2 prongs that it can go to. Well, they go to the start and run windings of the compressor. And the way that it works is that most of the electricity is going to go from the neutral wire to the start winding. after the compressor starts, then there's going to be a certain amount of heat that is generated in this PTC thermistor, and it will increase the resistance to the start winding and allow the electricity to now flow to the run winding to allow the compressor simply to run. So you would possibly think that, well, maybe this component, the thermistor, the PTC thermistor, is a bad component. We can test this compressor directly without this PTC thermistor with this device right here. We'll do that in just a moment, okay? Before we do that, let's just see if we, let's just check this PTC thermistor to see what it's doing. Well, if I take, I'm on continuity right now. Now I've already, there's three leads that go on the side of the compressor, 3 electrical terminals. Now come on over here to the board, and I'm going to show you what those 3 terminals are. There's one at the top and the 2 here. Those are the 2 prongs that go right here into the PTC thermistor. This top prong is the one that was connected to the overload protective device. I've already ohmed everything out with there's no electricity on the compressor, and I was able to find the common start and run terminals. And the way that you do that is I just did a little pictorial and drew the 3 dots, and then I measured the resistance from these 2 points, these 2 points, these 2 points, and I wrote those resistances down. Well, we know that the highest resistance is going to be a combination of the start and run windings. So I knew that this was R or S, but I wasn't sure which was which. Then the last terminal had to be the common, so I put the C there at the common. Once I established that that was the common, I looked at the resistance from the common to the other 2 terminals. The one with the higher resistance should be the start winding. The one with the lower resistance should be the run winding. So with that in mind, this PTC thermistor plugs in like this. The lead on the left side facing this way should be the start winding. So what I did was take my meter, put it on continuity, go into the start winding, go into the spade terminal here, and I have 100, I have no resistance. It's pure pass-through. So it's already passing the electricity through cleanly through the system and right into the compressor on the common terminal and on the start winding. So this appears to be doing its job. It's supposed to do that to start the compressor. Now there's a couple more things that I can do here. Another thing I can do to verify that electricity is actually going to this unit is I can take my meter, put it on voltage AC, and put it here on the 2 windings, the 2 spade terminals, and I can then start it up and then see if I actually have the correct voltage going to these 2 places. So I'm right here. I got that like that. Got this right here. I'm going to turn it on. As you can see, I got 119 volts going to the compressor through these 2 spade terminals, through the overload protective device as well as the PTC thermistor. And still, this compressor was not running. Okay, so I shut that off. Now, just another verification to see what's going on with this compressor is we'll use this device. We're not even going to use this. We're going to use this. Now what this is, when you plug this in, this is a made-up test strip that was made up in school. When you plug this in, you're going to have 110 volts across these 2 leads right here. Okay? The red one, I believe, is the hot, and the black one is the neutral in this case. This line here that's green is going to be the start terminal. So you can put this alligator clip here on the start winding, put the other two on the common winding and the run winding. So the red one here is for the run winding, that's why it's got the letter R on it. Once the compressor starts, if this was a normal compressor, once it starts, push in this and it will take out the 110 volts going to the start winding. So that way you don't have that in the circuit. So I'm going to connect this on right now. It'll just take me a second to connect it on, and I'm going to try to do that. And that way we can test it. Now I know that the run winding is the one on the left-hand side because I did a little drawing. That's the common one right there, and this last one here. And you know what, before I do that, there's one, well, I already also checked, but I'll do it right now just so that you can see it on the camera. Before I did any of this testing, I also took the meter, put it on ohms, which is right there. And I touched from pure copper, the copper leg right here, to all of the winding terminals of the compressor. You can see that that is not, I am not open, so I'm not grounded. In other words, this compressor is not grounded. I also checked the ohm reading from all the 3 ohms that you saw up there, and they all appear to be normal. Those are good numbers. The start to run winding had 30.2, common to run 15.3, and common to start 15.9, and nothing is showing to ground. Those indicate a good electrical motor. So electrically, it looks good. Physically, it looks good. I mean, it looks almost brand new. Okay, so now with that test completed, nothing is plugged in, we're still off here. And I'm going to go ahead and connect this, wire this back on. Okay, so this goes to the run winding. This goes to the start winding. This one goes to the common winding. Right there. Now I can plug this in. Right there. Shut this off. Now, if indeed this unit is going to start, I can go to amperage AC. I'm going to put this on the common terminal. I could put it on any one of the 3, but I'm going to put it on the common terminal. And turn that on there. And I've got this right here, my push button, once I start it up. Okay, here we go. 6 amps, push the start button, it goes up to 8.6 amps. All I heard was a humming. So, this compressor is mechanically seized. Maybe the pistons and the cylinders, or something to do with the internal mechanical components. Somehow this compressor is simply seized. This compressor needs to be replaced. I've already called up the supply house to ask how much for a replacement compressor. This compressor, parts only, not including sales tax and shipping and all that, is $154. Well, this whole refrigerator probably doesn't even cost $154, so we're not going to replace this compressor. But I just wanted to go through the steps that you would take in order to troubleshoot this type of a compressor. Thank you for watching. Okay, we're back to this compressor again. I usually don't come across trying to free a stuck compressor, so I originally thought, well, you know, I'm just going to condemn it. I did a little looking in the textbook to see what further steps could be done. And there's three things that can be done to free a stuck compressor in this particular case if you truly want to get this thing down to the last wire. Now these aren't guarantees, but these are attempts that you could make to try to free a stuck compressor. The most inexpensive way, and we're going to try and do this one first, is just putting electricity on here and giving it a tap to see if just that vibration will free it. Then the second method, this is a 120 volt compressor, we'll introduce 240 volts to try to free it momentarily to see if that will get this compressor to run under normal conditions. Then the third method is to use a hard start capacitor kit. Now we do not have one of those in our inventory, so we won't be able to try that, but that would be the third attempt that you could use to try to start a stuck compressor. So I'm going to hook up this test lead here, and I'll do that right now. I know that the run terminal is on the left, and hook that up. The start terminal is right next to it, which is going to be this green lead, and the other one is the common. When you hold this in, it takes out the start lead, the start thing. This here is my test strip. When the lights are on, the power is on. So right now the power is off. And I'm just going to give myself a little extra protection with some rubber electrical rated gloves 00, just in case there's a shock potential here. And I'm going to do this as fast as I can. Okay, here we go. Hold on a second. I got one of the leads came off when I did that. It never did start. One of the leads came off. Hold on a second. I can get that plugged in. This one, like that. Just want to try to keep this up here. I don't want those to fall. Alright, I got them on there as best I can at this point in time. Okay. I'm going to get this as tight to this as possible so I can try to do two things at one time here. And I'm going to attempt this again.
Lucy used to hang little things out in front of her little wood thing.
Okay. You can only do this for a couple seconds at a time. You cannot leave this in the circuit long periods of time. This method, the hammer method, is just not working. I'll try it one last time. But I do not believe we're going to get success here. No, this never did start. So I'm going to get 240 volts. I'm going to have to create a wiring situation to try that. So we're going to pause, and then we're going to see if we can introduce 240. Okay, we have hooked up two different phases of electricity here, so that if I turn both of these power strip cords on from the hot lead here to the hot lead here, we'll get, I think it was about 208 volts, which is double the 110 what this compressor is. Then I hooked up a temporary extension cord from each of them. I got 110 volts on the common leg on this power strip cord and 110 volts on the hot leg only from this leg to the start terminal. Now I have both of these off at the moment, and what I'm going to do is I'm going to turn them on, and then I'm going to turn them off, and I'm only going to leave this on for 1 second, 2 at the very, very most, but more like 1 second. I'm just going to attempt this because this is unusual. and I'm not sure what's going to happen. I'm going to take a little extra precaution by putting on my safety glasses and my electrically rated gloves, just in case this thing just has a real hard time or something really weird happens. I just want to try to be somewhat protective of myself with some personal protective equipment. So it's already connected on. I got the switches right here, and here we go. It's humming, but it's not doing it. I'm going to try to hum it and start it like this. Okay. That's not working. It's not starting. So even with 240 volts from the common to the start leg, now I'm going to take and move the start leg onto the run leg, and I'm going to try that. So both of my power strip cords are off. Just to give myself a little extra protection, I'll actually go ahead and unplug them, just to be safe. And I'm going to move over one lead, the lead that went to the start terminal. I am now going to move that one over onto the run terminal, and I'm going to put the other one back on the common, and I'm going to try this. This is our last attempt that we can possibly do to start this unit. Everything's off. Plug that in. Plug that in. I'm going to put my gloves on, and this will be the last attempt that we can possibly do to start this stuck compressor, because we do not have a hard start kit. And here we go. No, it is not starting. I tried it. I'll try it one last time, but this doesn't look like it's going to be a go. No, we have no go. So I just wanted to demonstrate a couple other techniques that you could possibly do to start a stuck compressor. I don't have the hard start kit, so I can't demonstrate that one there, but at least I could demonstrate the hammer test with just 110 volts. I doubled the voltage to an unusual 208 volts, which is not a normal situation for this compressor, but even with the double voltage, it's not kicking over. All I'm getting is that hum. So again, you know, we're condemning this refrigerator, and we're saying that the compressor needs to be replaced. It's $154. We're not going to do that for this $125 refrigerator.